It's projected that 2035 the global energy consumption increases by 37% from today's levels, with India and China accounting for half of the growth according to BP. In order to give a broad view about hydrocarbon fuels, in 2014, 80% of the total primary energy supply was based on fossil fuels such as oil, natural gas, and coal. In recent decades, large-scale production of shale gas has been considered as a major issue in the US energy industry. In accordance with the great economic potential and environmental concerns, shale gas process and supply chain optimization has become one of the most popular research areas. Hello, I'm Roshdy Ebrahim, and you're watching the Energy Economist channel. Shale gas is known as unconventional natural gas extracted from shale rock layer and has emerged as one of the most promising energy sources within the last few decades. With the discovery of huge shale gas reserves all over the world, a shale revolution starts in the US and keeps spreading out in other countries. In 2005, the US barely produces any natural gas from shale formations. Nowadays, nearly 44% of the total natural gas withdrawal is from shale gas wells. According to the Annual Energy Outlook 2015 by the US Energy Information Administration, natural gas production is expected to grow by an average rate of 1.6% per year from 2012 to 2040. As a result, the percentage of the US total natural gas production from shale gas is expected to increase to 53% by 2040. The remarkable development of large-scale shale gas production would not be possible without the hydraulic fracturing and horizontal drilling technologies. Different from the conventional natural gas, shale gas is embedded in the shale rocks that can be a few thousand feet deep. Therefore, special techniques are required to withdraw this unconventional resource. By using hydraulic fracturing, millions of gallons of fracturing fluid, about 90% water, 9.5% sand, and 0.5% chemical additives is pumped underground under high pressure, up to 70 MPa. Fracturing the rock layer and holding fractures open, thus forcing the shale gas and or oil to flow back to the surface. The horizontal drilling, on the other hand, is a drilling process in which the well is turned horizontally at depth. Compared with the vertical drilling, horizontal drilling allows us to drill multiple wells at a single shale site. As a result, a horizontal well site is able to produce more energy with fewer well bores, which significantly reduces the capital investment and improves the efficiency for shale gas production. Shale gas production of a single well normally features a high initial production rate followed by a astounding decline from 60 to 90% after the first 3 years. This characteristics is mainly caused by the pressure depletion and inherently low permeability of the reservoir. Consequently, operators need to regularly drill new wells to maintain a stable production profile, which results in a scheduling problem. Additionally, based on the composition, shale gas can be classified as a dry gas and wet gas, and the key difference is the content of natural gas liquids. The natural gas liquids are defined as light hydrocarbons including ethane, propane, butane, and heavier components, which typically have sustainability higher market values than methane gas. Dry gas is almost pure methane with trace natural gas liquids. Although methane is still the dominant component in wet gas. The amount of natural gas liquids is significant enough to require further processing. Depending on the location, both the estimated ultimate recovery and shale gas composition of a shale well may have significant variance. All of these issues render the optimal design and operation in the shale gas industry a challenging topic. The shale gas produced at shale site is generally considered as raw shale gas that needs further processing. The processing surface is typically provided by midstream processors. Through the shale gas processing, impurities such as compounds and gases, oil and water mixed with the natural gas are removed. Two major products, pipeline quality, sales gas and the natural gas liquids, are extracted and sold separately. The sales gas is normally delivered to major interstate and interstate pipeline transmission systems and further sent to final customers. The natural gas liquids, on the other hand, can be used as feedstock for the production of value-added chemical such as olefins and gasoline blending stocks. With the rapid development of shale gas industry, excessive supply of natural gas liquids requires more cost-effective shale gas processing designs and conversion alternatives for a better use of this valuable byproduct. Despite the great economic potential stimulated by the shale gas, one major concern impeding the expansion of shale gas industry is its negative impact on the climate change. Methane is about 10 to 5 times more potent greenhouse gas than carbon dioxide based on the 100-year global warming potential. A small amount of methane leakage could lead the enormous greenhouse gas footprint. Additionally, supply chain activities such as shale gas production, processing, transportation, and gas-based power generation could incur large amount of greenhouse gas emission as well. There have been extensive studies published evaluating the life cycle carbon footprint of shale gas. However, the shortage of decision support tools and methodologies still exists, which requires the development of corresponding optimization models for more sustainable design alternatives in the shale gas industry. If you want to learn more about global perspective of shale gas production, you could do so in my book, Economics of Oil and Gas Production, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and don't forget to also hit the notification bell. Thank you for watching and goodbye.